Parallel Industries 220, Engineering Academy, Master Course, Lesson 2, Part 3, Systems Engineering, the Architecture of Innovation, Professor Dr. Jessen. Welcome back. Today's lesson is not about a single machine. It is about something much larger. It is about understanding why great engineering organizations are able to transform ideas into systems and systems into progress. Throughout history, the world's greatest achievements have never been the result of one brilliant individual alone. They have always been the result of disciplined teams working on the shared principles guided by ethics, supported by a knowledge committed to excellence. The difference between invention and engineering. Anyone can imagine. Very few can design and engineer. Ideas are unlimited. Engineering is disciplined. Can you be disciplined? Ideas begin with imagination. Engineering begins with responsibility. Can you be responsible? Every drawing, simulation, verification, design review, prototype is a promise. A promise that reality will behave exactly as mathematics predict. That is the difference between invention and engineering. That invention, idea, or prototype. An idea may inspire the future. Only engineering can build it with responsibility. System thinking. A common mistake made by young engineers is believing that they are designing a component. They are not. They are designing interactions, a language. A motor cannot be understood without the transmission. The transmission cannot be understood without the structure. A structure cannot be understood without manufacturing. That cannot be understood without an economics and a society supporting all that activity, all that engineering, all that development, all that research, all that activity take place at the same time. Everything is connected. That philosophy is called systems engineering. A system succeeds only when every subsystem succeeds together. Analogy. Think about an hospital. A surgeon cannot save a patient alone, and he may be the greatest surgeon in the world, in the planet, in the region, in the continent, but he will still need to work with the nurses, with the professionals working in the laboratory, the sterilization team, the biomedical engineers, the emergency department. Everyone is a component working for a structure, for a system. All become part of the same system. All those components are working together in one single component. Even the greatest, because it's the greatest component of the world, doesn't mean that's gonna succeed. Success belongs to the entire system. Failure also belongs to the entire system, not a single component. The whole structure, the system, all components working together. That is systems engineering. The PI 220 philosophy. Within Parallel Industries 220, we do not develop isolated technologies. We develop engineering ecosystems. Every architecture, every subsystem, every innovation must contribute to something greater than itself. The PI 220 core coordinates information. The Neo core coordinates intelligence. The X2M engine coordinates prediction. The PCTM architecture coordinates energy. The advanced systems coordinate aerodynamic efficiency. The Starframe architecture coordinates structural intelligence. APS infrastructure coordinates mobility. VHX platform coordinates mechanical efficiency. Different technologies, one engineering philosophy, integration before complexity, discipline before speed, verification before implementation. Ethics. Technology without ethics is only capability. Engineering with ethics becomes responsibility. Transparency is engineering. Traceability is engineering. Independent verification is engineering. Peer review is engineering. Admitting uncertainty is engineering, because confidence must never replace evidence. The strongest structure is not built upon confidence. It is built upon verification. The value of a team. Engineering is a profession, not an individual performance. The aerospace engineer needs the material scientist. The software architect needs the electrical engineer. The manufacturing engineer needs the quality inspector. The project manager needs the technician. The researcher needs the operator. Great organizations never compete internally. They cooperate professionally. Respect is productivity, and communication is reliability. Therefore, trust is efficiency. Analogy. Consider an orchestra. One violin cannot perform a symphony, neither can one trumpet. Each musician studies a different discipline, yet together they produce one masterpiece. Engineering organizations follow the same principle. Individual excellence creates competence. Collective excellence creates civilization, success, continuous improvement. There is no perfect prototype. They are all prototypes. They teach us how to build a better one. Every simulation reduces uncertainty. Every experiment improves understanding. Every validation builds confidence. Every failure reveals information. Engineering advances through disciplined learning, not through assumptions. Humans were machines before machines could ever imagine becoming human. What distinguishes us is not our ability to calculate, but our ability to question, to learn, to care, and to improve. The responsibility of leadership. Leadership in engineering is not measured by the number of people who report to you. It is measured by the number of people who grow because of your example. A true engineering leader does not seek recognition alone. He seeks understanding. He develops people before projects. Because technologies evolve, machines evolve, software evolves, organizations endure only when people evolve together. Final message. As our journey through the PI 220 engineering ecosystem continues, remember this. Every architecture begins as an idea. Every idea becomes a model. Every model becomes a prototype. Every prototype becomes a lesson. Every lesson becomes knowledge, and knowledge shared with integrity becomes progress. Never measure engineering by the complexity of a machine. Measure it by the confidence it inspires, the lives it protects, the opportunities it creates, and the future it makes possible. Because engineering is not merely the construction of systems, it is the construction of trust. The future belongs not to those who build the most complex machines, but to those who build the most trustworthy ones. Excellence is achieved when intelligence, discipline, ethics, and humanity work as one. Professor Dr. Jessen, end of lesson 2, part 3, Engineering the Future, Elevating